All right, so welcome back. We're going to start now with the first unit of the last unit of the course. If that makes any kind of sense. And that is, of course, the digestive system here. When we think about the digestive system, we're going to break it down into basically two parts. So there's the tube that runs from basically from your mouth to your butt, right? This is the alimentary canal, right? Or the gastrointestinal GI tract. And this is going to be really the functional, well, not the functional, but when we think of digestion and the processes involved in that, this is kind of the big part of it, right? So we're going to be doing both, excuse me, mechanical and chemical digestion. We'll talk about the differences between those things a little bit later on. A little more detail anyway. For right now, suffice it to say that mechanical is kind of like chewing, right? So when you take a big thing and you break it into smaller pieces, okay? And then the chemical side of it is when we take those small pieces and we actually break the molecular bonds within it and get down to atoms and molecules and stuff like that. That's chemical digestion. And then from there, we move to absorption, okay? And of course, the whole way through, we have transport occurring, moving from one part to the next the whole way on through. The other part of the digestive system here, these are the accessory organs. So these would be things like teeth, your tongue, your gallbladder, your liver, your salivary glands, your pancreas, all of those kinds of guys that are kind of adding little bits of stuff along the way. So here is a kind of a crowded diagram, but it's the one in your book with really all of the parts here, honestly. Most of this stuff I suspect you're probably already familiar with, right? But as we get through here, we will eventually go all through all of these different parts. And so it'll be a good idea to kind of have this diagram back your mind, or at least the idea that it's there. It's 23.1. So that as you go back, if you need to refresh some of this stuff, this is a place that you can go back and do that. Now, before we get into the organs themselves, just like we saw with the lungs and the pleurae and the heart and the pericardium, we're going to have a series of membranes that surround most of, not all, but most of the digestive organs in that same way, right? And so the membrane, the serous membrane that we're going to be talking about here, again, like we had the pleurae, like we had the pericardium, this is the peritoneum. And the peritoneum, like those other two membranes, right, is divided into a visceral and a parietal component. The parietal lining the body wall, the visceral covering the organs. Again, here it's important to remember that with this particular system, we're going to have some organs that actually exist outside of the peritoneum. And so organs that are not covered by it, we're going to refer to those guys as retroperitoneal, right, behind the peritoneum, and we'll see what that looks like in a second. And the ones that are within that peritoneum, we call intraperitoneal. Now, one of the important things about this, right, is that we're going to see that this peritoneum has a series of folds in it, where we get this sort of double layer bit of tissue. And these are what we call mesenteries, right? And again, on the next slide, we'll see a picture of that. And it's just where we've got kind of two parts of the peritoneum kind of next to each other. So not against a body wall, not against an organ, but kind of next to each other. And within that little space between them, this is where we can run blood vessels. So we've talked about the superior and inferior mesenteric artery before. They're going to pass through some of these mesenteries. Nerves, all of that kind of stuff can travel from back by the spine, where the big blood vessels and the spinal cord, those all run. They can move forward to these organs through these mesenteries. The other thing, right, is of course that, like with, again, the pleurae or the pericardium, there's a fluid-filled cavity between the visceral and parietal, and that's the peritoneal cavity. And it does the same thing it does anywhere else. It's there largely to lubricate the organs so that as they jostle around, as you move, as you digest, right, they don't rub on each other and wear on each other. All right, so let's look at some pictures here. This first picture here, We've got two different sections, different transverse sections through the abdominal cavity here. Obviously, here is the back, right? So we've got the spinal column here. And then this tube in the middle is meant to represent the alimentary canal. All right. And this dark orange line is the peritoneum. This part here lining the body cavity on both of these is the parietal part. This part here lining the organ, the alimentary canal, is the visceral part. And you can see that as the parietal part comes forward, right, to wrap around the alimentary canal, there's this little chunk right here where there's really just two parts of that peritoneum coming together, and that's what a mesentery is. You might imagine it, say the abdominal aorta sitting right here, right? It could easily pass branches forward through that mesentery to get to some of these organs. The space here between these two, okay, is the peritoneal cavity. Depending on where we are, so if we're a little bit lower in the abdominal cavity, right, we're going to have only a single mesentery, that's the dorsal mesentery. But a little bit more superior to that, if we get closer to, say, the thoracic cavity, where we might encounter, say, the liver, what we're going to find is that, yes, there's a dorsal mesentery, but we also have a mesentery connecting the alimentary canal to the liver and the liver to the anterior part of the body wall. And so we also have a ventral mesentery in certain parts of the abdominal cavity as well. As far as being retroperitoneal, for the most part, when we talk about the kidneys later on, those are organs that are primarily retroperitoneal. They are grown, they spend their entire life in the space back here behind the peritoneum. For the digestive system organs, the alimentary canal organs here that are going to be retroperitoneal, they're what we call secondarily retroperitoneal. And what happens is they begin life intraperitoneal, like our guy is here, right? But during development, they get moved back and they end up contacting this visceral peritoneum, or excuse me, the parietal peritoneum back here. And what can happen when we do that is we can actually get this part of the peritoneum merging with this part of the peritoneum and kind of going away. And so we end up with the peritoneum kind of just tucking around this side, and the part of the canal, the organ here, is actually now stuck entirely behind it. So that's all we mean by retroperitoneal. As far as histology goes, we're used to kind of thinking about these tube organs as layers, right, or as tunics. We saw these with blood vessels, lymphatics, same thing is going to apply here. We have our innermost layer here is a mucosa, because again, our alimentary canal is open to the outside world at two places, right? We have both a mouth and a butt, right? And both of those are connected to the outside world. So the membrane lining those tubes, therefore, is a mucous membrane. And this mucosa, depending on where we are in the canal, is specialized to do different things. It might be specialized to secrete certain chemicals, mucus, digestive enzymes, whatever, okay? Or typo here, obviously. Or later on, we're going to see more absorption as the primary capacity, taking the digestive nutrients and absorbing them into the bloodstream. Surrounding the mucosa, we have the submucosa, which is where we find nerves, blood vessels, lymphatics, or lacteals were present. We have a two-layered muscularis externa, right, with two layers of smooth muscle, a longitudinal and a circular layer here. And then the outside layer is the serosa, right? This is the serous membrane. This is the visceral peritoneum, okay? We're also going to see that there are a couple of exceptions to that. So the esophagus, again, another typo. I did this early on, sorry. The esophagus is not in the abdominal cavity. And because it's not in the abdominal cavity, it can't be surrounded by the peritoneum. So the outermost layer of the esophagus is called the adventitia. For retroperitoneal organs, we have both a visceral peritoneum, again, another typo, my goodness gracious, a visceral peritoneum and an adventitia. Okay, so again, some minor exceptions. This is what it looks like, right? A chunk of our alimentary canal, just a generalized chunk. It's not a particular part. Here we've got our mesentery in the back, so this will be attaching us to one part of the body wall or another. We got our van parked in here, right? Our vein, our artery, and our nerve. Also a lymphatic that goes with that. These enter into this submucosal layer. All right, and they travel within the submucosal layer surrounding the mucosa in here. All right, this innermost layer, our two-layered muscularis externa, the outside. Okay, and the last outermost layer here, of course, is the serosa, or an intraperitoneal organ. This, of course, is the excuse me, the visceral peritoneum. Okay, so let's begin our journey here. We're going to walk our way from one end to the other, talking about the structures within those things, talking about the processes that occur within them as well. And so we've got two choices, really, where we're going to begin. Most logically, I think we'll start with the mouth. Okay. Technically, this is the oral or the buccal cavity. Sometimes you will see this pronounced or hear this pronounced, I guess, as buccal. Those people are wrong. It's kind of a inside anatomy joke, but buccal is the kind of the correct way to pronounce that. And that's going to be this kind of, well, it's where a lot of your accessory organs are going to sit. Some of them are going to be outside of that, but this is, again, the beginning of the journey of our food. So teeth, tongue, some salivary glands, most of your salivary glands are actually outside of it, but drain into it. So let's take a look here at one view of this oral cavity. We're actually going to divide the mouth here up into two different cavities. Outside of the teeth, but inside the lips, right? So where, and I hope you're not, but if you're the sort of person that does chew tobacco, this is where you would put your wad of tobacco. This region here and here in the lower jaw, this is called the vestibule. Okay, and then inside of the teeth, right? That's really our boundary here. Inside of the teeth, we call this the oral cavity proper. Okay. So again, we're gonna subdivide those two things out. Obviously, of course, we have teeth, right? We have connections between the lips and the gums, which we're going to call gingivae, or gingiva is a singular. This is a frenulum, so we have a superior labial frenulum, labial here meaning lip. So the superior labial frenulum connects the gingiva of the upper jaw to the upper lip, and the inferior labial frenulum connects the gingiva of the lower jaw to the lower lip. Within the oral cavity proper, we have another thing here kind of similar to that. We have a frenulum here for the tongue, so the lingual here meaning of the tongue, lingual frenulum. Okay, and just below that, we can start to see some of the openings here to some of, but not all of, the salivary ducts. In lateral view, I would hope some fairly familiar structures here to us, right? Things we've seen before. Nasal cavity up here, nasopharynx, oropharynx, laryngopharynx down here. The one thing that we probably haven't really talked about a whole lot is this little floppy bit of tissue back here called the uvula. That is what this guy is right there as well. And of course, the tongue here with all of its various muscles, extrinsic and intrinsic both. So let's start with the teeth here. The job of the teeth, as you might imagine, right, is to tear up and to grind food. Okay, it's really just there for mechanical processing. Now, the average adult has 32 permanent teeth, although most of us have 28. The reason for this we'll get to in a second. These are your adult teeth. These are the ones that do not replace. Okay, but as a child, and starting at about age 6 and running up to about age 12, you began to lose some of these. You have 20 deciduous teeth. And the difference between the permanent and deciduous counts is that the molar teeth, the ones in the way in the back, do not replace. They are not deciduous. You get one shot at a molar. We're going to be able to divide, again, this is a typo. Man, this is a wonderful lecture for you guys. I'm sorry. Obviously, there are 4 classes, not 3, of teeth, starting from the midline and moving our way lateral to that. We have the incisors in front. There are 4 upper and 4 lower. The canines, 2 upper and 2 lower, right? So 1 right, 1 left, 1 right and 1 left. 4 premolars upper and 4 premolars lower. Again, these are the ones that replace. So you get 2 of each of these in your life. And then behind, we have the molars, 4 to 6 in the upper jaw and 4 to 6 in the lower jaw. This difference between 4 and 6, there's never 5, right? You either have 4, right? So you have 2 upper right, 2 upper left, 2 lower right, 2 lower left, or you have 3. And that third one on each quadrant are your wisdom teeth. So most of us that have them have had them removed. Those of us who have not, who did not have to have them removed, we may not have had them at all. We're starting to see a lot of people where these wisdom teeth never actually come in. So just to kind of give you a sense for, again, what these teeth look like, we've got these chopping teeth, slicing teeth here in the front. These are our incisors, right? These 4 guys right there. We have a pointy canine on each side of those. We have 2 on each side and 2 in each quadrant of these premolars. Sometimes we call them bicuspids. And then right in the back here, we have the grinding teeth, these molar teeth. In terms of the structure of a tooth, it's fairly complicated, honestly. We're going to divide it into 3 big chunks, depending on our relationship to the gingiva, to the gums. So the part that sticks out of the gum, sticks out of the gingiva, it's called the crown. The part that's kind of covered by the gingiva is called the neck. And the part that's in the bone, part that's actually in your jaw, is called the root. Now, as far as the tissues that go into making up each of these teeth, the entire length of the tooth is going to be built out of this material here called dentin. Dentin is relatively soft, but it is something we can continually grow. So if you damage the dentin of your tooth, it will repair itself. The reason for that is that this part is right next to the living part of the tooth, right? Here called the pulp. You can see in here there's nerves and blood vessels and all that stuff living within there. The outer part of the crown is acellular, non-living tissue called enamel. And enamel is really, really hard. It's the hardest material your body will make, but you can't replace it. And you can't repair it. So if you have damage to your enamel, that enamel is gone. It is not coming back, right? Regardless of what various toothpastes will try to tell you, if enamel is gone, enamel is gone. The tissue that makes enamel no longer exists on an erupted tooth, right? So you cannot repair that outside of dentistry. Within the root, right, again, we have dentin and we have pulp, but the outermost layer of tissue here is called cementum, or cement. And the job of the cementum here is to attach to this guy right there and right there called the periodontal ligament. The periodontal ligament holds your tooth by the root in the socket in your jawbone. Now it's a ligament and it's not a fused bone because that ligament allows for some small amount of flexibility. Your teeth can move a little bit in their sockets. Not a lot, they're not supposed to move a lot, they move a little bit. And that's going to help out with shock absorption, okay, and other sorts of issues that might otherwise come up. The tongue is a skeletal muscle. It is entirely, well, not entirely, but primarily under conscious control. Its job is to reposition and to mix food, okay? And we're going to turn that wad of food in your mouth into something that we're going to call a bolus. Okay, so the part that you swallow is called a bolus. The other job we've got here, obviously we have taste, right, with our old friends, the taste buds, filiform, fungiform, valate, and foliate papillae, things we've talked about before. The other thing we're going to do here, we haven't gotten into a lot of this stuff yet, but we're going to secrete a digestive enzyme. It's called lingual lipase. And a lipase helps to break down fats. So this is a fat digesting enzyme from your tongue. Doesn't mean that you actually digest in your mouth. Well, not fats anyway. You secrete it here, but you actually turn it on in your stomach, but it's something we secrete starting here. The salivary glands, there are two varieties of these guys. There are ones that exist within the oral cavity. They're called intrinsic, but there's not a lot of them and they don't make a lot of saliva. When we think about making saliva, we're thinking about the extrinsic ones. These guys lie outside of the oral cavity, but drain into it, right? Functions of saliva here, they help clean your mouth out. They provide a watery solution for food to dissolve into tastants so we can taste. Help to compact and moisten food as we form it into a bolus, okay? And we do have some digestion here, not of fats, but of carbohydrates using a class of enzymes called amylases. So if lipases break down fats, amylases break down carbohydrates. This is under largely autonomic control. So the parasympathetic, the rest and digest, is going to increase secretion. The sympathetic, the fight or flight, is going to decrease it, right? So if you've ever had dry mouth, when you've gone up to give a speech or something, right, we call this technically as xerostomia, under any kind of those stressful situations, this is why, right? When you're in stress, you're under sympathetic control, and that shuts down all of your salivary glands. There are a whole bunch of these guys. We're going to get into these guys a little bit here. First, the parotid gland is right here at the angle of your jaw. Okay. The submandibular gland is below your jaw, and it's going to kind of wrap around. You can kind of see it, there's a little C shape here, wrapping around the mylohyoid. And then below the tongue, we have the sublingual gland. Okay, these little green lines here, these are all the ducts that drain into the mouth. The final thing we'll cover in this video here, deglutition or swallowing. Deglutition is the fancy name for that. There's two phases to this, right? One of them is voluntary and one of them is involuntary. The buccal phase is the voluntary one. And what we're going to do here is we're going to take the tongue and we're going to push that bolus against the roof of your mouth. And if you look at our little cartoon down here, you can see that the roof of the mouth is actually angled kind of up and back. All right. And so as we push the tongue up against the roof of that mouth, that kind of squeezes the food back past the uvula into the oropharynx. Okay. Once it's in the oropharynx, we enter the pharyngeal phase. This is involuntary, right? Here, we're going to use a process called peristalsis that we'll cover in the next video and move that food from the oropharynx through the laryngopharynx and down into the esophagus. Okay, so we'll stop there for now. When we come back, we will cover the middle chunk of our journey and then we'll move on from there.